Okay, so when it comes to cyclic alcohols, when you want to name an alcohol that is part of a ring of a cyclic chain, then you will use the prefix cyclo, and because the OH, the hydroxyl, has priority over the other things that you might have here, over the halogens or the branches that you might have here, the substituents that you might have here, wherever the OH is located, that will become carbon number 1. Remember, when you have a ring, any of the carbons could be number 1. Now, if you have a branch, whatever that branch is, this is going to be carbon number 1. But if you have something more important than just a branch, than just a substituent, such as hydroxyl, the alcohol, this will take the priority, and the carbon where this is located is going to be carbon number 1. And you can start, you might believe that you can start counting counterwise, but because you also have a substituent here, the bromine, then you have to count in this direction. You will always pursue to have the substituents in the lowest possible numbers. All right. So you have carbon number 1 here and carbon number 2 here. And because this structure has 6 carbons, it's a cyclohexane. But because you have the OH, you substitute the E at the end of the word hexane by the suffix ol, and then it's going to be cyclohexanol. But you have to state any other substituent that you have in the compound, like the bromo, which is in carbon number 2. So you have to name this 2-bromocyclohexanol. Now, somebody might be wondering, but it says trans here. Is it because the bromine is a transgender? No, it's not. No. It's not because of that. It's because the bromine and the OH are not to the same side. You see how the bromine is to this side of the carbon? The H is in the next side of this H, this hydrogen is in the next side of this. So because they are in opposite sides, you can call them trans 2-bromocyclohexanol. If the bromine is here, then that would be cis 2-bromocyclohexanol. The bromo is the name of this substituent. The cyclo is because the chain is the ring. The hexane is because you have 5 carbons in the chain. And the ol is because you have the hydroxyl, the alcohol's functional group. The same thing we could say about this. Yes?
Can we backtrack to the trans part?
The trans part? Okay.
I don't understand that.
Okay, this is what happens. If the OH, the functional group, which is the guy that has a priority here, and the bromine are in the same side, you see how this hydrogen atom is here, very close to the OH compared to the bromine, I mean. Because they are not back to back, you call them trans because it's like in the opposite side, is across from this guy here. They have something in between. Now, if the bromine is here, right next to the OH, that would be cis, C-I-S, cis 2-bromocyclohexanol. But because it's not next to it, right next to it, they call it trans. You get it?
Nope.
Okay, it's just the orientation.
Okay. The part that I don't get, you call it trans because where the alcohol and the bromine is, or where the hydrogen and the bromine is? Because it looks like the hydrogen and the bromine are right together.
Yes, these two are together, but we're talking about these two, the hydroxyl and the bromine. If the two of them are together, back to back, then would not be trans. But because they are not, you call them trans.
Okay.
this is not as important. I just don't want to leave the stuff behind. Like, okay, don't worry about that. I always want to explain everything, but I wouldn't go too deep into that because that's not as important. It's still the same kind of compound. Right, so this guy here, we have another cyclic alcohol. Now we have a 3-carbon shape here, 1, 2, and 3. So it's going to be propane, but because we have the OH is propanol. And because it's part of a ring of a cyclic chain is cyclopropanol. Also, we have a substituent. We have a branch here that has 2 carbon atoms. So this is ethyl, 1-ethyl cyclopropanol. Okay, notice that here they are not paying attention to the number of the carbon that contains the OH. Why not? Because it's always carbon number 1. When it's obvious, they don't state the number where the OH is located. Okay, what happens if you have 2 different functional groups? You have the OH, which is for the alcohol, but you might have the double bond, which is for the alkene, or the triple bond, which is for the alkyne. Which one has priority? If you have a double bond and the OH and the hydroxyl group, which one is going to be more important? Well, just read the second bullet point there. Can somebody read it for me?
The alcohol functional group takes precedence over the double and triple bonds. So the chain is numbered in order to give the lowest possible number of carbon atoms bonded to the hydroxyl group.
That's correct. So the position of the OH is given by putting its number before the ol suffix. This is what they use in the modern nomenclature of the UPAC. Now, the numbers for the double bonds or triple bonds were once given early in the name. Let's see one example of that. We locate the longest chain, the one that contains the OH group, and it has 5 carbons. Even though we have a double bond here in the first carbon, starting from this end, this is not where we start counting, but in this end. Why? Because the OH has priority over the double or triple bond. So this will be carbon number 1, this will be carbon number 2. And then you will name this as, let me see, because my 4-pentene 2-ol. Notice that this method of naming the alcohols is important because if you have a double bond and you have an alcohol, how would you say where the double bond is and where the alcohol is? This is a pentanol, for example, pentanol, because the in here is for the double bond and the ol is for the hydroxyl, for the alcohol. Now, if you just say pentanol, you have to say where is the OH and where is the double bond. So what they do is they state where the double bond is by putting the number before the word, and in between they put the number where the OH is located. Is that clear?
Yeah, kinda.
Definitely not.
No? No? Oh boy. Let me repeat what I just said then. Because you have in carbon number 4 a double bond, but in carbon number 2 you have the OH, the most important part of this compound. Okay, you have to state the numbers where these two things are located. You cannot state the 2 numbers in the beginning of the word to start naming this. That's why you can just put the number where the double bond is in front, and then the number where the OH, which gives the termination ol to this, you can just put it right before the suffix here. Notice that we have seen 2 different ways to name this. cyclohexanol, and let me go even backwards here. If you try to use this method, it wouldn't be enough, because here, well, you're naming the branch methyl. Here, these two that you have in front is for what? Is for you to know where the alcohol is located, where the hydroxyl is located in carbon number 2. Now, you wouldn't be able to follow this method if you have a double bond within this chain, because the moment you have a double bond, you have to state it in front of this word where the double bond is located. So you cannot put the number for the double bond right next to the number for the OH. So you put in front the number for the double bond, and in the middle, like here, the number for the alcohol. That's what they are trying to explain here in this example. When you have double bonds and alcohols, just put the number for the double bond in front and the number for the alcohol right before the suffix. That's what they are trying to say in a short way. But we will find some examples, and I will explain it with more examples. Some consideration: OH is hydroxyl or hydroxy when it appears on a structure with a higher priority functional group, such as acids, esters, aldehydes, and ketones. Remember that we saw the various functional groups, like the carbonyl. This is called carbonyl, and when it's present in a chain, this is an aldehyde when it's all by itself. But when when this and the OH are in the same carbon, this is a carboxylic acid. Now, this is more important than the OH. So you wouldn't start counting here because you have an OH here. This is now in a second place because this has priority. This has precedence before this. So this would be how you would start counting. And this compound is no longer an alcohol because it has this, but it's an carboxylic acid. And don't worry about that strange name. We are going to go over that later on. All I need you to know is that sometimes the OH is not the one that has preference, the one that has priority. When that happens, like in this case, you are going to name this as just a substituent, as a branch. You will name this that this is in carbon number 3. So we have a hydroxy in carbon number 3. This is not going to be butanol because you have this here. This is not going to be the most important part of the chain, but this functional group will take priority. And this is just going to be named as a substituent. Wherever you see this as a substituent is going to be named hydroxy, okay? This compound, for example, is, this compound, for example, this compound, for example, is butanoic acid, and it has a substituent that is hydroxy in carbon number 3. Here you have another example. You have a hydroxy in carbon number 2 in a ketone. This is important. I will allow you to take a picture of this or screenshot it. La faja pateando, está jugando fútbol. A eso pasa. Okay, so if you ever see alcohols and alkenes in the same chain, you know that alcohols are going to be more important than the alkenes. Now, if you have alkenes, if you have a double bond, and you have a halogen, these are the halides, you know that alkenes are more important than the halogen. So you will start counting wherever you have the double bond instead of wherever you have the halogen, chlorine, bromine, fluorine, etc. Now, if you have alcohol and you have aldehyde, the aldehyde is going to be more important than the alcohol. So as you go down, priority decreases. These are the functional groups and how they relate to each other in terms of priority. I believe that the picture has been taken already, so I'm going to move on. Now, what is this thing that we call diols? Ponlo en la nevera para que la moca no lo visite. A diol is when you have two OHs. Is it possible to have more than one? Yes. Look at this. Look at this example. You have 1, 2, 3 carbons. We start counting here because we have an OH closer to this end than to this end. So this is propane 1, 2 diol. I also saw this name as 1, 2 propane diol. Instead of having the numbers in the middle, I used to see them in front. 1, 2 propane diol. But nowadays, the modern nomenclature is propane 1, 2 diol. Can we have even one more OH within this chain? What do you think? I'll repeat the question. Is it possible to have any other OHs on this chain?
Yes.
Yes. Where?
Number 3.
On this carbon. In that case, would be glyceride. Do you remember that we talked about that? This is the guy that is present in the lipids. Glyceride is actually propane triol. Propane triol. 1, 2, 3 propane triol, or propane 1, 2, 3 triol. Tri because you have 3 of them. Actually, you can have even more. Because wherever, again, wherever you have an H, you can add something else. Okay? We have the same thing here now in a cyclo, in a cyclo alkane. Okay, and to come to an end, because it's already 11, what happens when you have OHs as part of a benzene? I told you that they are called phenols. Remember, we talked about this ortho, meta, and para. Ortho is 1, 2, meta is 1, 3, and para is 1, 4. I also told you that 1, 5 doesn't exist because if you have something here, let's say that you start counting here, here would be number 2, here would be number 3, here would be number 4, and here is not going to be number 5. What is going to be here?
Number 3.
Number 3, because in that case, you would start counting from this side. That's only if you have 2 things, because of course, if you have one thing here, one thing here, and one thing here, one is supposed to be number 5. Okay? So this particular thing is called bromophenol, because I mean 2 bromophenol. And this could be cis bromophenol because they are, it looks like they are to the same side. But don't worry about that, the trans and the cis, I'm not going to go very deep into that. So because,
question.
yes?
I feel like I'm behind or something, but where did the benzene go? Because this is the benzene structure. Why don't we call it
Yes,
benzene,
yeah, that's a
bromobenzene
benzene.
or something?
That's a benzene. It's a hexagon with 3 double bonds inside.
So when you have 2 branches off of it that's not carbons, you just don't say benzene anymore.
Okay, wait a second. Wait a second. Let me see. Hey, bajen la voz, por favor. Let me see if I understand what you're saying. This is a benzene. We're clear on that,
Yes.
right? This benzene has an OH, a hydroxyl group, and that makes it a phenol. The fact that the benzene has the OH makes it a phenol. Actually,
So
we
it's
use
no longer called benzene.
no. If it has this, it's called phenol. Okay.
Okay.
So we have a phenol here, and this phenol in carbon number 2 has a bromine. So it's called 2-bromophenol because in carbon number 2 it has a bromine atom. Or you can also call it ortho-bromophenol. Ortho means 1,2. In carbon number 1 is where you have the OH, and in carbon number 2 you have the bromine. So ortho-bromophenol. In this case, this substituent is called nitro. So this is 3 nitrophenol or meta nitrophenol because they are in 1 and 3. Every time you have 1,3 is meta. And this is 1,4. The OH is in carbon number 1, the ethyl is in carbon number 4. So you can call this 4-ethylphenol or para-ethylphenol. Have you heard any word that, yes, I asked you about that, the paracetamol that has, it's kind of a phenol that has something here, actually an acetic acid that we will discuss later when we get into the carboxylic acid. But for now, these are called phenols, and whatever substituent you have there, you just put it, name it before the word phenol itself. Again, the phenols can be monohydric, dihydric, or trihydric. Depends on how many OHs you have there. You have 2 here, and you have 3 here. You might even have 1 here. If you have 1 is phenol. If you have 2, is benzene 1,4 diol or para diol, benzene diol. And this is triol because you have 3 of them. Okay. Some common names. This guy that you see here, I'm going to start with this one. This guy is a rubbing alcohol that you buy on the drugstore in the pharmacy. Rubbing alcohol is actually 2-propanol or I'm sorry. Okay, we'll continue with this in the next class. For now, I'm going to stop the recording.